Yeah, so our talk we're going to be kind of showing you how you can combine real-time analytics and generative AI, because we have to be hipster enough to do a talk in July 2023. So our talk begins with me attempting to get from London, sort of up here on the left-hand side, down to Nuremberg in Germany on the right-hand side. So flight number one, all good. I then got to Frankfurt airport, sat there for about 4 hours, and then they cancelled the flight, and I came back home again. And this is how I found out in the airport that my flight was cancelled. So I got this message, which, I mean, it's factually accurate. It goes, hey, your flight on this day from Frankfurt to Nuremberg is cancelled. Please accept our apologies. We are looking for alternatives for you. We will be in touch. They didn't get in touch, and nor did they come up with any alternatives. Instead, I ended up in this situation, which I guess many of you may have experienced in an airport. And so you sort of end up in this queue with loads of people, all basically trying to answer the question, well, what am I supposed to do? What do you suggest that I do now? Do I take another flight to get there? Should I just come back home? What should be my best option? And so I was thinking about this a few weeks ago. So I was like, I wonder whether we could do something better than this kind of quite generic email where it's sort of the flight's cancelled, figure it out. So I mentioned it to Dunith, and he was came up with this idea of maybe we can combine our two loves of real-time analytics and, of course, playing around with OpenAI and ChatGPT and friends. And so we thought, let's see if we can build a demo showing how to do this. And so that's what we're going to do in this meetup. Don't consider this to be an absolute solution, but consider this as a spark for some ideas of stuff that you could do. So I'm going to hand over to Dunith now, and he's going to just give us a quick introduction to generative AI.
Yes, thanks, Mark. Hi, everyone. I'm Dunith Dhanushka, Senior Developer Architect from Redpanda. For those who are new to Redpanda, it's a Kafka-compatible streaming data platform. That means if you already have Kafka producers and consumers, you can seamlessly integrate it with Redpanda. So if you are curious to learn more about Redpanda, you can check out the links posted in the chat. Yeah, so that's about me. And then we come back to our session. And Mark, having heard of your story, I really feel sorry about the situation you have to go through. So let's try to find out a solution to stop that kind of situations keep happening in the future. And having said that, we have generative AI at our disposal. Next slide, please, Mark. So what is generative AI? So it's been overrated for a couple of times by different media outlets and social media. So basically, it's a subset or a subcategory of artificial intelligence that gives you the ability to for a computer-generated computer model, machine learning model, to generate a content based on human input, right? So that's the gist of the definition. In order to understand it better, I think we can use this diagram in the slide. So as you can see in the middle, we have the generative model. So this is a machine learning model designed, built, and trained by machine learning engineers and data scientists. And you can see we have a brain connected to it. So this brain is its memory or the trained data set. So it has all the past interactions about users, the things in the world, everything has contained in this past data set. And then we as humans, we can interact with this generative model through a natural language interface. We call it a prompt, right? So this prompt can be something like a question, asking a machine a question, or you can command it to perform certain things like a certain task. So it could be a command or a question or generic conversation like good morning or whatever. So it could be in plain English, Italian, Spanish, could be anything. And then the generative AI model understands this input and then synthesize an output, and it will output it in the form of a textual response or an image, music, a piece of music, or a video. something like deep fake videos you've seen in the YouTube. So that's how you connect all these dots. All right, next, yeah. And then in the recent development of this ChatGPT, DALI, and this Google Bard and all these woes, AI woes, certain media outlets and influencers and social media platforms, they have made us believe that generative AI is all about ChatGPT and OpenAI. But the truth is, it is not. So there are so much behind that in generative AI. It's like when we talk about electric cars, Tesla does not represent all the electric cars. So there are so many electrical vehicle manufacturers, like Mercedes, BMW. So they all have electric variants. Next slide, Mark. And then when we go to the landscape of this AI application, generative AI application, you can see it's vivid and very diverse. You can expect more startups and applications to come out in this generative AI landscape. For example, we have many startups and technologies who help writers to make their writing better, and for developers to write better code, and for video and marketing professionals to get better with their videos and speech. And there are so many possibilities, and we can expect more to come. So yeah, and next slide. And then we generate. So what is the foundation of generative AI models? Like I said in the beginning, it's machine learning model, collection of machine learning models. Then in this list, so we can see transformer models like GPT-3 and GPT-4, GPT-4 being the latest deployed in the OpenAI. And then we have a plethora of machine learning models like GANs, RNNs. You don't have to, I don't want to bombard you with all these things, jargon, but just think these are differently designed, purposefully designed machine learning models designed to carry out specific tasks. For example, some models are good at performing anomaly detection, while some are good at doing personalized recommendations. So we can explore these things as we progress. Next slide, Mark. And then we have the other side of the coin. What is real-time analytics? I think the best person to
back to me.
is Mark. Yes, back to you.
Okay, so what is real-time analytics? So this is the definition that Gartner gives. And probably the most interesting part of this definition is the bold bit, right? So the idea is we can provide insights for making better decisions quickly. And it's the making better decisions quickly that's the most interesting bit. So these systems, they tend to center around having the collection of events, where an event represents some sort of action that happened generally in the past, right? So in our flight scenario, it could be that a flight was scheduled, a flight was delayed, it could be a customer checked into the flight. If it was another domain, perhaps it's that you signed in to the webinar, perhaps you registered for the webinar, you joined the Meetup group. There's all sorts of events that are happening. And the events on their own are okay, but what we really want to do is gain some insights on those events, whatever that might be. And it often will involve looking at multiple events kind of aggregated together and come up with some action, something that we can do. So in the case of the flights, it was, well, I need to know what to do. Like, do I book a new flight? Do I get a hotel? Do I get a train? What do I do? Like, so we want like somebody to do something in real life. Either it's going to be the company who has the data, or it's maybe even better going to be the users are going to do something. And when we're working with real-time data, the data from our perspective decreases over time. So it's at its most valuable when it just happened. So the flight delay just happened. Okay, cool. Let's sort out like what we're going to do about that. And it decreases as time goes by. So we're interested in the left-hand side of this diagram. And as we drift towards the right-hand side, sort of as time-wise, that becomes sort of the realm of like the cloud data warehouses, where maybe we're looking at the data the next day or the next week, and we're not so interested in coming up with an action that we can do now, but it's more like having a look historically, like what happened, what can we learn from this data, what can we do? But it's a different type of use case. So how do these two things work together? So I'm going to hand back to Duneth, and he's going to talk us through these next few.
Yes, And now that we understand just a glimpse of generative AI, and then Mark has just given us a brief description about real-time analytics AI. Now let's see how we can marry these two concepts and extract the best of both worlds to build up super interesting applications. The key thing to remember here is that they are not competitors. I mean, generative AI being a new concept, and it's not going to replace or act as a drop-in replacement for real-time analytics. They will augment each other. They will complement each other with their best features. Let's see how. Next slide, Mark. When you look at a typical real-time analytics system, something like a stream processing system or streaming database, you can identify two planes, data plane and the control plane. So the data plane is the infrastructure that ingests raw data streams, process them, transform them, and emit insights, real-time insights in real time. So that's the machinery, that's the muscle. And then on top of that, we have the control plane. That's the brain. So what do you do with the control plane? We as application developers, we program our processing logic in the control plane. So we can use imperative languages like Java, Python, etc. Or we can use a declarative approach like SQL to write this kind of processing logic, like something like, okay, join these streams together, join this with a static data set and come up with this unified thing and output it to something somewhere else. So that's the pattern. Now, what if we strip out this control plane and plug a generative AI model like a LLM into the control plane? That will give us more opportunities to write more expressive, or most importantly, write the stream processing logic in a more natural language way. So that's the goal of this presentation today. So in this demo, in this webinar today, we are exploring certain ways we can use a prompt to build a real-time application. So having said that, we all know that real-time analytics systems are distributed systems in nature, and they're being really built and tested to be fault tolerant, scalable, and respond in ultra low latency. So that's the good parts of real-time analytics. And then when we talk about generative AI, they are really good at understanding natural language commands, and also they can synthesize different things with their internal representation and come up with the cool things like what's the next best alternative. So it's pretty much easier to let a model do that rather than writing a bunch of line of code. So that's what we are going to do today. And can we advance the slide? Next slide. Right. When we combine these two together, we can unlock several use cases. The goal of this thing is because real-time analytics systems, they've been always working with your corporate data, your business data. How can we use real-time analytics systems to work with LLM application? So that's the bridge. So that way we can enable corporate employees to query business data with LLMs. For example, asking questions, something like maybe an analyst in the organization asking, how is my business is going to perform over next quarter? Is it going to profit or lose? Or you can provide support agents for customers, and then customers can chat and ask, am I eligible for a extra luggage for the flight, right? Because the agent has been trained and injected with corporate data. And also provide a hyper-personalized user experience to customers based on the real-time interaction with the business. So this is what we are going to demonstrate today with Mark's amazing demo. And the next slide. All right, I'm going to hand it back to Mark. Yes.
Yeah, so I guess what's kind of weird about combining these two sets of technologies together is that real-time analytics is all about fast data, right? Like there's lots of data and it's coming in all the time. And LLMs are slow, right? So they generally takes a few seconds to get a response, like, and you can't really put it into a real-time flow. Otherwise, it's going to slow down everything. Like in the time that it's taken to process maybe one request or one event, there's probably like another 500,000 that are on the queue. And so we came to the conclusion that what we actually need to do, if we're going to hook these two approaches together, we probably need to be funneling the messages. Like we need to be working with the subset of them, where maybe like if the response takes a few seconds, maybe 30 seconds, it's fine. Like it's not like absolutely urgent that you get a response in milliseconds. And so for the flight notification system is a reasonably good fit for this type of problem. There are other ones, as Dunith has described, but this is what we're going to look at. So we're trying to come up with some requirements to sort of guide what we should build. So we said, okay, well, we're going to send out notifications if we get a cancellation, or we're going to focus mostly on delays. We don't want to bombard the customer with options like, hey, these are all the flights that are happening today. No, we don't want to do that. We want to go, here's the suggestion. And we want to personalize it to that person. Like, can we narrow it in something that is specific to them? And so we're going to see how close we can get to achieving those requirements. This is the architecture of what we're going to build. It seems like there's a lot of boxes, but the way to think about it is on the first line with the cool Redpanda logo over here, we've got some streams. So we've got customer actions, flight statuses, massage delays, and notifications. And then if you come down up to the next, we've got build, and each of those you could consider they're like a microservice, like a little service that is responsible for doing just one thing, and then it's going to write the output into another stream. So if we come from the left, so we're going to have some flights. Some flights are going to be scheduled. Maybe some flights are going to be delayed. We'll then have customers checking in and booking those flights, and then we'll have a customer list in the database as well. The delay service will then come in and go, okay, I've got a delay. Who's been affected by the delay? Go and get all their details and send that up to massage delays. The personalizer, and so the things on this level, the first two, these are running a stream processing library called Quix, which is kind of like, I think of it as like Faust 2.0. So Faust is like a tool written by the people at Robinhood, and it's doing stream processing in Python. So you can basically do your whole stream processing application in Python, and it then allows you to integrate with any other Python tooling. So you can literally do whatever you want in Python. In our case, we're going to be integrating with the LLM's Python SDK. So we feed it all these events. They're coming in and you're like, hey, here's all the messages. And it's like, cool, I'm going to generate you a nicer looking English message. And I'll put that onto a new topic up here, the notifications topic. And then if this was real life, we'd have a dispatcher, and maybe it would do a push notification to your phone or send an email to you. But for our sake, we're gonna show it on a web page. So just to zoom in on the tech stack a little bit, so we've got Redpanda, that's in charge of all the streams. We've got Quix, that's going to detect flight delays and then trigger the customer notifications. Pinot is going to be sort of sitting in the back with an overall latest view of what is going on in terms of the customers. It's going to find the customers who are affected by delays and then find future flights that those customers can book into. And then finally, we've got OpenAI sitting on the far side, and that's going to generate notification messages from the data that's come from these other three. So just to quickly zoom in, what have we got? So remember, we've got 4 data streams. So we've got customer actions, and those are going to be booking confirmations and check-ins. We've got flight statuses. Those are the flight scheduled events, and then many fewer flight delayed events. We've got massage delays. So that's where we've got the flights plus confirmation information for those people affected by the delays. And then we've got the notifications, and that's going to be like the raw messages that need to be sent out. So here's some examples of the events that we're going to be working with at the beginning of our real-time data pipeline. So we're going to have some flight statuses. It's going to have a flight schedule. It's going to indicate where the flight goes from. So for simplicity's sake, we're assuming that everything is going from Heathrow. And we've just literally just used the generator to come up with made up airlines and locations and times. And then we're going to have a scheduled departure time, a scheduled arrival time, an aircraft, and then how many seats it has. And then the customers booking into the flights, this is what it looks like. So we've sort of, again, automatically generated, hey, they booked into a flight. This is which one it was. This is when they did it. And here's the booking reference. If you want to have a look at the demo, that we're going to do, let me just paste that link. Where did it go? So I'll just paste this. Oh, maybe not with my party emoji, but let's see if this is going to work. So if you want to have a look at the demo, all the code is over here. The line break has messed it up. Dunithor Yarden can fix it while I work through it. So yeah, this is what we're going to look at. And maybe I can actually show it on the screen as well, just so you can see what does it look like. Let's see if that loads. Yeah, there we go. So this is what the code looks like, and you can see there's kind of a bunch of stuff in here. If you want to follow along, all the instructions are in here. So this is what we're going to be doing. So I'll just come back. I'll come over to my terminal. Okay, so we've got some topics already created in Redpanda. If you wanted to create them, you can basically run this command here. So we're going to use this tool called RPK, and we can say RPK topic create. We'll give it a cleanup politicians, and then we can actually create multiple topics at the same time. And if we do it this time, it's going to say, hey, these topics already exist. But if you run it the first time, it will obviously create them.
Mark,
what we're going to do next.
Just to add to that, so this RPK is the CLI tool, command line interface, that is you can work with Redpanda. So with that, you can do certain administrative tasks on Redpanda, like creating topics, setting ACLs, and creating partitions, and etc. Yeah, just wanted to add to Mark's details. Yes, carry on, Mark.
So it's called Redpanda Keeper. So we'll paste that link over here as well then.
Yep.
Okay, so what we want to do next is we're going to have a look at our data generator. So you just so our data generator should be here. So I'm not going to hang on. This is a bit longer. So what this does, so we'll just start at the bottom. You don't need to memorize this code. I'll just quickly run through what it does. So effectively what it's doing is it generates a bunch of flights, so 600 flights. Where does it start? So yeah, it generates a bunch of flights going from London Heathrow to somewhere, and then it publishes those to the Redpanda flight statuses topic. And then just under there, we then schedule, we've got a bunch of customers, we've got 100,000 customers, and we book all of them onto a flight. And again, we publish that, but to a different topic, customer actions. And then what we're doing after that is we've kind of got a loop every 5 seconds, which is sort of checking in. Where's that? Where's it gone? Up here, it effectively randomly decides, shall we check in somebody to a flight? And if we should, then we check someone in, right? So it's just simulating customer bookings. I know the code has kind of got a bit wrapped, but that's more or less what it's doing. So what we're going to do is we're going to run that. And this will then, so we'll sort of leave that running on that tab. And what we're going to do is we're going to come over to one of our other tabs over here, see? And we're going to run this command with the RPK tool again. So what we're going to say this time is our topic, consume some messages from flight statuses. We'll tell it where Redpanda is running. And then we're going to use the JQ tool to parse it. And this is what, maybe I'll do, hang on, let's just make it one message so it's a bit easier to read. So this is what one of our messages looks like. I guess we could actually maybe even, can we do like that? Oh no, then it messes it up. Okay, we'll just leave it like this. So we get the flight schedule, we've got a bunch of data, we've got the flight ID, the airline, we've got the departure airport there, we've got the arrival airport, we've got the scheduled depart time epoch, and then a scheduled arrival time epoch, and then we've got the aircraft information as well. So those are the flight schedule events. And then we've got the same sort of thing for the consumer actions. So let's see if we can do that. Maybe we can just, can we do, oh, sorry. Yeah. Let's just do that. So this is what a consumer action message looks like. So we've got, again, we've got a message type because there are different types of things. We've got a booking confirmation, and then we've got the data. So we've got the flight ID, we've got a customer ID or passenger ID, the timestamp of when they booked it, and then a booking reference as well. And there are loads of these events. So if we took this off, it will keep going for ages. So it's probably better not do that. So the first part is working pretty well. So we've got those streams of got messages coming in. The next thing we want to do is put that data into Apache Pinot. So when you're putting data into Pinot, Pinot is good for like really wide tables. In this case, I mean, this table is, I guess, not that wide, but it's a column store. And so we need to define like you define data in tables, which have columns. And so what we've got here is we're going to call our table flight statuses. This table in particular is going to be what we call an upsert table. So that means you need to specify a primary key, and I'll explain the upsert bit in a minute. So we're saying the primary key for this table is flight ID, and then we specify some dimension fields. So similar language is what you would see in data warehousing. So we've got we've got message type, flight ID, airline, departure, and so on. And then we've got a date time fields, a couple of date time fields down here. We can then see the same for the table config. So a schema and a table config kind of come together. So the schema defines, okay, what's the data going to look like? And the table is, okay, and this is actually what we're going to do with the data. So again, the name needs to be the same. We've got a real-time table, so that means it's expecting some sort of streaming config somewhere. And so what we're saying is our schema is flight statuses. It's a real-time table. That means we also need to specify a time field, which in this case is going to be the scheduled departure time. This is the streaming config. So as Dinith mentioned, so Redpanda means we're kind of sort of Kafka API compatible. So we can say, hey, I've got my Redpanda running here. This is the name of the topic. And then we can use we're passing in JSON messages for simplicity. You could do Avro if you wanted to, but yeah, for simplicity's sake, we're using JSON. And then if we come down a little bit, we are sort of doing some extra work down here. I'll explain the transform configs first. So what we're saying is, remember, everything was nested under data. And so you can do a little bit of transformation inside Pinot. So we can pull out the flight ID, the airline, the departure airport, and the arrival airport. The other thing that we're doing that you might have noticed is we're specifying a filter config. Now, a filter config is, what you're saying there is, when the data is coming in, I want you to run this this predicate to check whether or not we should ingest the message. And somewhat confusingly, in my head at least, a true means that we're going to filter it out. And so what this line here is saying is, if it's not flight schedule, filter it out. So i.e. if it is flight schedule, we're going to keep it. So we're just keeping the flight schedule messages. I've got completely baffled by that a few times. And then a couple of extra configs that we need to say we're using upsert mode down the bottom. And then once we've done that, we can go and create our table. So we do that like this. So we say, I've got to call the add table command. I've got my schema file, the one we just looked at. I've got my table config file, and I've got my Pinot host. So give that a few seconds, and eventually you get a message saying, yay, I've created that for you. So let's come over to my browser. We'll give that a refresh. So this is the Pinot UI. So what we've got here, so you can see we've got the tables. So we can have a look at this table config. So if we look in here, we've got flight statuses. Notice it's connected to the flight statuses topic in Redpanda. I should have also mentioned that Redpanda has an equivalent UI. So this is the Redpanda console. So you can see I've got all my topics in here. And if I don't want to write, like using the Redpanda Keeper tool, I can come in here. I can have a look and see what the messages look like. You see it's really nicely formatted in there. I can have a look at the key if I just wanted the key. I can look at the value. I can search these. So I can say, hey, find me the oldest messages, for example. And these are the oldest ones that were ingested. And then I could create a message in here if I wanted to. And then you can see up here, it's telling me I've got 600 messages in here that are taking up 256 megabytes. If I had any consumer groups, I'd be able to see them here. We've got a breakdown of the partitions. So you can see we've got 5 partitions that we created for this topic, and you can see the number of messages and then the low and high offsets that are currently there. So if you were to prune the data in here, you would see the update on this page. And then we can also have a look at the config behind the topic. So you can see we're retaining the data for 7 days. The retention bytes policy is infinite. And you can configure, all of these are dynamically configurable. So they will get picked up whenever the segment next rotates. Were we to have set up a schema registry, it would be visible in here. Okay, so let's just come back to Pinot. So Pinot is pulling in the data from Redpanda, and this is what we've got. So we've got it's quite a small table, right? So we've got just 600 messages, 600 records. And if we have a look down here, so we can see we've got these airlines, we've got the aircraft type, all the departure airports will be Heathrow. And we probably didn't need to store the message type just to show you that that's what it's ingesting. And then we can have a look. So these are the most popular destinations. I've just created like a random distribution, and so it's kind of chosen which ones it thinks are the ones that should get the most flights. So we've got Los Angeles, we've got Charles de Gaulle, Bangkok. I don't recognize necessarily all the airports on here. I'm not well traveled enough to have been to all of them. So that's the flight statuses. Let's now have a look at the next one. So this was the customer actions. So we're going to do a similar sort of thing here. So we need to create a customer actions table. Again, booking reference is acting as our, so this is an upserts table. So booking reference is going to be our key. And again, we've got the different fields, the message type, flight ID, booking reference, and then timestamp is the timestamp field. And again, table configs, this is going to be really similar. So you'll probably get quite familiar with the outline of these files. So again, name of the table, type is real time. Only thing that changes down here is we point to customer actions. And then we don't have any filtering this time, but we do still want to pull out the things from data. So booking reference, passenger ID, timestamp, and again, and this time it's slightly different. So it's a partial upsert table. So what that means is that we're not going to try and replace every field on every new message. We're going to just pick up a few of them. So we're going to overwrite the message type when that comes in, but other stuff we're going to ignore it. Okay, and then what we'll do next, let's create the table. So let's create that table. And then if we come over here, now we've got two things. So you can see we've got a bunch of customer booking requests. The next thing that we need to pull in is the actual customers themselves. So let's have a look at how we can do that. So we've got the schema. So again, now this time, this one is just a normal table. So no upsets going on here. So we've got the customer ID, the name, the age, the gender, location, email, frequent flyer status, and a few other fields as well. And if we do the same for the table, so this one's going to be slightly different. So this time it's an offline table. And what that means is it's expecting us to ingest all the data from somewhere. So we could do it all in one go, or we could set up a job that's going to sort of poll, like, for example, an S3 bucket and pull the data in. And again, Pinot doesn't let you have spaces in column names. So we're having to do a bit of a transformation to fix that. And then what we're going to do, we're going to create that table. So let's create that table. And then we're going to be pulling in the data from this file. No, the input, where did I get it from? Was it data? Yeah. So we're going to pull in the data from here. So we've got a big CSV file here with loads and loads of different people. And what we can do is, so we've mounted that to the endpoint, /input. And what we're going to do is we're going to tell it to ingest that data. So we can say, it's a local Pinot file system. We're going to tell it where the customers are and then insert into the customers table. And so we should, so now you can see we've got 100,000 customers. So those are all, have all been pulled in. What we can do now is we can do a quick check. So we can say, hey, let's have a look at the checked in customers. So who's already checked in? So remember, we've got that loop going in, pulling in the customers. And then for one of those customers, we can then check. And so what we're doing here is we're going to say, let's get a booking reference, and we're going to look up all the customer actions. And this time we're saying skip upsert. How big is this? So skip upsert true. So when you have an upsert table, by default, it picks up the latest status. What have I done wrong? Why is it not got our customer action? It should have got it right. Oh no, these ones don't have aren't checked in. Hang on a minute, just made a mistake. Let's have a look. So we should be able to get this one. And let's see, we put that one in. Then we should be able to look up the booking reference for that one. Let's try that. Yeah, there we go. So what it does, if we say skip upsert is true, is it just goes, okay, I'm going to treat it just as if it was a normal query, just get me everything. So when you use upserts in Pinot, it doesn't stop inserting the data. It still continues to insert the data, but then it has an in-memory dictionary sort of sitting in front of the table, and it only returns the latest record. So you can kind of see maybe a tiny bit small, but I can make it a bit bigger. You can see we've got the booking confirmation was on the 26th of June, and the check-in was today at 10 minutes ago. So what we want to do next is let's find, so we could also go and check like the details of the of the flights themselves. But I think what we'll do now is let's have a look at how we could trigger a delay. So we're going to find, let's go back to our query that finds popular destinations, and we'll do Los Angeles. So let's say we copy Los Angeles. So let's just copy that in here. And what we're going to do is we're going to do a second query that finds some flights from Los Angeles today. So copy those in. And let's delete that. So these are all the flights going from Los Angeles. The airlines are totally made up, so don't assume that those are the correct airlines flying to Los Angeles. And let's pick one. So I don't know, let's say we'll go for this one here, OM8940. If I then come over here, so we'll just paste that in here. What we're going to do is we're going to trigger a delay. Now, the trigger delay code, let's have a look at that. So we've got a script called trigger delay. Yeah, I'll save that one for a minute. So pigment eyes. So let's just have a look at what that does. So if we paste that in here. So we've got this script called trigger delay. And what it does is it writes a query, it finds a flight. If it finds a flight, it then connects it creates a producer for Redpanda, and we're going to generate a flight delay message with a new departure time, and we're sort of randomly deciding, we are specifying how much it should be delayed. It's then going to write the event into flight statuses with that delay message type. And then just for interest, we're also going to check who are the customers who are affected and print it out to the screen. We're using like a snapshot of Pinot, which has something called a multi-stage query engine, which allows you to do joins. So just in case you're wondering, how are you doing joins? That is how we're doing them. So let's just paste in our trigger command, and I'll just go back to here and let's get our flight ID. So we'll delete that. So we're going to, flight ID, and let's say it's delayed by 180 minutes. So it tells us, okay, we've kind of printed out, okay, we've got this delay to this flight. Here's the message that we've published to Redpanda. And then we've got a whole load. These are all the customers. We've got 168 customers affected by this. We can then write like a little query or a little command that checks, did we get the flight delay message into Redpanda? So again, we're just getting all the flight statuses, and we're using the JQ tool to say, hey, get me the message types flight delay. And you can see we've got our flight delay message in there. What we can do now is we can have a look at our service that's going to handle those delays. So that is called the delays service. Remember, that was the first service on our list. And this is where Quix comes in. So Quix is a stream processor, and we are using their Python. So it's Python and, as far as I know, C#, and we're using the Python API. And so you see we're setting up a streaming client around Redpanda. We're also connecting to Pinot on the line before. And so what we're saying is we want Quix to get the messages from flight statuses, and it's going to be treated as if it's the consumer group flight delay notification. So if you were to stop it and start it again, it's going to have detected, okay, there's an offset and I'm going to continue from that offset. I'm not going to go and reconsume a message that I've already consumed. And then we are manually then connecting to a producer as well. So this is what we're going to do later. And so what we do is we start off with, we've got a query up here. So this is a query that, so it's querying Pinot. It's going to find the departure time of the flight ID, the name of the passenger, the last the status of their last action. What was their last status? Was it checked in? Was it just booked the flight? Their email, loyalty score, number of flights, past delays, and so on. And then what happens in Quix is we then have effectively like a callback function. So every message from Redpanda is going to come into here, and we're going to do something with it. So what we're going to do is we're going to check, first of all, is it a flight delay? We're then going to pull out all the information. We're going to call that Pinot query here, and we're going to write a new message into the massaged massaged delays topic. And we're going to do that for every single customer who was affected. So you see we're looping through all the customers that we got. So it's going to create 168 or so messages.
So Mark, what you're doing here is enrichment, right? So you basically, for each message, okay.
Yeah, so we got I guess you're right. Yeah, so we got an initial message, and all we've taken out is the flight ID, and then we've gone and looked up all the customers from Pinot for that flight. We've got a bunch of information, which was all these columns up here, and then we are creating new messages that contain those. So we're not actually joining two streams. We've got one stream coming in, and then we're going out and going, hey, Pinot, what's the latest status of this flight? Okay, here it is. Let's put it into another stream.
Got
And
it.
so what we can do next is we'll run our delay stream on here, and we'll come over to this one over here. And we should be able to see our messages. So there we go. These are the messages that have been sent to the massage delay. So maybe we'll just do one again. So this is a message, and we say, hey, the arrival airport was Los Angeles. This was the initial departure time. Beth Rowley was impacted. She's only booked a flight. This is an email. I know these aren't in sync. She's a platinum member, though, has got a loyalty score out of 10. I think it's out of 10 or out of 5, maybe, or 1.17. Number of flights taken this year, 57. That's a lot of flying, very bad for the climate. Been delayed 9 times, and this is the new departure time of flight. As I say, we could also go and look at these messages in the Redpanda console. So we could say, hey, show me massage delays. And so if we then go to the messages, you can see we've got 168 messages, so 1 per poor customer who's had a flight delayed. And you can see, like, if you want to see like a cleaner way of looking at the data, this is where it is. So we can see we've got, I guess if we wanted to see the last one, which is what we just did.
You can also filter messages by pattern based on that.
Yeah, where do I, here.
Yep.
What should I filter by? How do I do it? Here?
Yeah, you can put whatever the text and yeah.
Let's see, Jody Hall. Yeah, there we go.
Yep.
Only one Jody Hall. So what, does it search across like all the keys? So like, are these all of our, these are all the bronze frequent flyers? Looks like it. Cool.
Cool.
Okay, so now what we want to do next. So remember the next step was so we kind of got on our diagram, we've sort of done this bit. We've put it into the delay service. We've now got the messages in the massage delays. Now we need to get them. Now we need the personalizer to do its thing. So I just want to just do a quick note about the personalizer before we look at it. So if we're using an LLM, normally we'll have a prompt of some sort. So like ChatGPT, you get a prompt. You can type something in, and it will then use the massive amounts of data that it's been trained on. And often this is done at massive cost, right? Like I think to train ChatGPT was like $50 million or something. So a lot of work and a lot of compute has gone into training that. But it does, if we asked it, hey, what shall I tell this delayed customer? It's going to be like, well, I don't know. It'll just make something up, right? It'll hallucinate some amazing answer that doesn't make any sense. So what we need to do is inject some context into the prompt using our own data. So our data is down here, and we want to get that into the prompt so it can use that. Now, there are generally, like, as I see it, sort of 2 ways that we can provide that data to the prompt. And where everybody is focused, or where the big attention is on this right-hand side. So it's like, you probably noticed every single database is now a vector database or has vector database support. And I think that works really well if you're building a chat application. So if you've got a chat application, you don't really know what someone's going to ask, and therefore you don't really know what context you need. And so it's very good for building, if you wanted to build a chatbot on top of your documentation, this is a really good use. So it's like, I don't know what you're looking for. You could ask literally anything. When you get that question, I need to go and work out what are the similar documents to what you've asked me, and put those into the prompt and then answer the question. Now, for us, we know exactly what we want to go in the prompt, right? We don't need to introduce that vector database, because we kind of know, well, what we want is customer the flight information, future flight information, the customer information itself. Like, we've already got it, so there's no need to go and put that into a vector database first. We can just do a query against like just a normal, like a normal database, so a Pinot database in this case. It could be that we could, in a future thing, maybe we could actually do some sort of window functions on the data that's in Redpanda and just feed that in, rather than putting it into an OLAP database. So I don't think you need to introduce a vector database for everything. So what does a prompt look like if you're doing what we're describing? So effectively, you've just got 2 parts. So normally when you've got a prompt, you go, here's my instructions, and it does something. This time we're saying, as well as those instructions, you've got a context above it. And so what it looks like, if we were manually doing this in ChatGPT, we would say, hey, here's all my flight information. I've got my flight number, the destination, it's been delayed, and there's a delay. Here's the compensation rules, and here's some information about the customer. And then underneath, our instructions are, hey, the customer's flight's been delayed. Can you generate a message to them telling them what to do? Also tell them if there's any compensation. Make sure you take their status into account. Platinum's the best, and then gold, and silver, and then bronze. Don't give them loads of information. Try and keep it reasonably concise. And so if we now come back to the personalizer, so you can see what this looks like in code, So personalizer. So, oh, sorry, I should have, again, piped that into less. It's a bit easier to read. So we're using a library called LangChain. I've probably got too many imports on here, but this is sort of a work in progress. And LangChain is like kind of a toolkit that sort of automates, like in this case, generating the prompts, but it allows you to do a lot more than that. But what we can do with it is we can create this, they call it a question. So we've got a question. By default, the context has the variable name context, but you can change it to something else if you want, and you can feed other stuff in too. But in this case, we've just got a context, and we're going to say, hey, there's some context, and I want you to do this. This is my prompt. It's maybe a little bit, LangChain is the library. And then what we do is we create a prompt template, and we're going to say, hey, I've only got my only input variable is context, and then we're going to create the OpenAI instance, and we're going to tell it I've got a Q&A chain. So it's just means question and answer. So I'm going to ask you a question. I need you to give me an answer. Again, we're also using another two. Actually, I don't know whether we're using that one. We were using it, but then I think it didn't quite do what we wanted. Yeah, so we're not actually using that. So there is, if you were doing generic, hey, I've got a query and I want to get the SQL results and put that into the prompt. There's another tool called Llama Index, and it has this thing called the database reader. And you can effectively just call the database reader, write your query, and it'll go, bam, there's the answer, put it into LangChain. We're kind of doing that manually. Again, there's a bunch of Quix code here. So we've got some Quix code connecting to the massage delays. And this is code you will probably not need, but we have 168 messages in there. If we were just to run it, it will just run through all of them and process everything and create messages for all of them. For the sake of my OpenAI account, we've written like this cancellation token, so we can just do one at a time, so we can kind of see what it does. So we don't run out my entire credit card bill in one go. But what we're doing in here,
Mark, just a quick question. So at this point, maybe we have this obvious question: will it only work with OpenAPI or GPT-4 models, or can we use different?
So you can. So where we did this bit here, OpenAI, we could have plugged in any other tool. So you can use the Hugging Face models, you can use the Facebook or the Meta Llama models. You can pretty much plug in anything here that is. So as I say, this time we're using a tool called Lang. I wonder if we can. Let me see if I can find it. So often you get to the page better if you say Hugging Face. So they've got like integrations for everything. So we are doing. Where's our one? So we're doing OpenAI. So effectively, we are doing the equivalent of, where is it? We basically did OpenAI. So we've done we've imported this and then we've created it. You could do Hugging Face, right? So you could say, hey, I want to use a Hugging Face model. And then you could get the Hugging Face pipeline and it will do a kind of a similar thing, right? They've got an API for doing stuff with their models. So you can kind of take your pick. They have integrated with so many things, even like databases as well. I guess OpenLLM is maybe another, that's another example of sort of running hosted large language models. I haven't tried that one, but that one will work as well. So if we come back to our code, so yeah, we're using OpenAI, but I've tried it with Hugging Face and it kind of works with that as well. What we're doing then is this is how we create our context. I'll show you where it's called in a minute. So we're manually creating that context. So remember, the context is this bit in orange. And so we are manually like pulling in the flight ID, the destination, the departure time, the new departure time. And then we're also writing a query to say, hey, find me a flight in the future to that same arrival airport where there are some seats. And then we're running that against Pinot. And we're getting back some flights. And then what we do next is we are randomly picking a flight for it. I found I couldn't quite figure out, I'm sure there's a way to do this. I was giving OpenAI loads of flights and I said, pick a flight. And it was like listing all the flights. And I was like, don't list all the flights. I just want one flight. But I don't know how to get it to do that. There must be a way to do it. But I just simplified it and did it inside this code first. And then what we do, so this is what the context looks like. So we are manually constructing this. So you create what they call a document and you literally just build like the string. So we're saying delayed flight, these are the details. The new flight, these are the details. The compensation rules. So I just made these up. I looked at British Airways and I was like, okay, these are the rules for British Airways. So we'll just say those are the rules. And then these are the frequent flyer statuses. We made all this up. And I was like, here. And then if we go into the loop, what we're doing is, so this is extra stuff, but this is just so we can handle only one message. But effectively, you would just have this stuff here. And so what it does, it goes and creates the context based on the message. It then sends it to, in this case, OpenAI. It gets a message and then sends it to the new producer, which puts it into the notifications topic. And that is literally it. So the only thing I need to do extra before we run this is put my OpenAI key in. And now we can run this thing and see if it's going to publish a message. So it's going to do only one message at a time. So we can kind of run it. And you see it sort of comes up with, it's found a message. So it tells you the message. This is the context it's then given to OpenAI. It's like, hey, I've got this flight, it got delayed. And this is the message that it's going to generate. But what I want to show you now is just one more tool. So we actually got like a little tool that has got like a server-side events wrapper around the Redpanda stream. So if I just come over here. So I'll put this on. Is that big enough? Yeah, it's pretty big enough.
Yeah.
So if we put that over here, what we can then do is we can do another one. So, oh no, sorry, I killed the wrong thing. Hang on a minute. I meant to kill the thing. I meant to go over here. So we've got the message to Danny Dixon. If we then run it over here, we can come up. Let's see what it comes up. Let's do another message. So you can see it still takes a few seconds to do this. And this is what I meant by, you don't want this sitting like in the flow. I mean, I'm sure we could make this a little bit more concurrent and have it kind of do like more message. Oh, I thought I started that again. I think I made a mistake. Hang on a minute. Let's just start this UI again. So there you go. So a little bit of these messages is the same, but it does vary a little bit. So you kind of get like messages coming in and it says, we understand this is a convenience. It's been delayed to this time. Sometimes the suggestions that it comes up with are a bit dodgy. Like I think we maybe need to tweak the prompt a little bit. Like it's telling this person, hey, get a new flight. You're going to get £200. This person, because they get £500. Judith was also pointing out we probably need to like log an audit trail of what on earth the chatbot has promised people so that we actually fulfill it. And you can see sometimes it mentions, hey, there's loads of seats available. Sometimes it tells people to get on the next flight. Then an extension for this would be probably like, hey, so you can see this person got actually like a much more compressed message than the other one. Although it was again.
Yeah, just to add to that, what Mark has showed, so you can treat this screen as a personalized message coming to your web application or mobile application or maybe a voice assistant. So the key here is each and every message is different, right, Mark? And it's personalized and caters to all these things. Yeah, and
if we had different flights and delayed them by different amounts of time, I think we'd see even more of a difference. Like if we delayed the flight by like half an hour, I don't even think it would bother. We'll just say, yeah, just wait. It's kind of fiddly to get that set up, but we'll write this up into a blog post and sort of show you what would happen with different scenarios. But I want to just come back to our slides again. So this is more or less what we were wanting to show you. Like this is the flow. So just to conclude, so kind of hopefully what you take it away. So don't apply an LLM on every message. Just pick like a subset of events. And I guess what you would want to do, so you can see it kind of takes 3-4 seconds for the LLM to come up with an answer. So you don't want this to be like blocking stuff. Like you ideally want it to be somewhere where, like if your flight's delayed, if you get a message within a minute, that's probably okay. Like we could scale that out, like do that on multiple calls, send out those messages, and everybody will have like something useful within a minute. And the next thing I want to point out is every single article you read about LLMs says, get a vector database, you need a vector database. And we were like, well, do we really need a vector database? And I think sometimes you don't. Like if you know what you want to do and you're not doing a chat sort of generic application, don't put a vector database in there for the sake of it. Like just give it the data. And like, as is always the case with, if you see like demos in a talk, it's not a complete solution. There's way more stuff that you could do. Treat this as a proof of concept. It's not perfect, but hopefully it gives you like an idea of where these tools can be joined together. And there are loads of extensions that you could do to this. The problem is, in a little demo, they make it way more complicated. Like we could bring in, like, imagine we had like the trains, like we could bring in like the train schedule. We could bring in hotel bookings. We could tell them like about the restaurants that are near to them. Like if we know like where they are, like where their phone is or whatever, we could say, hey, this is where the restaurants are located. There's like a lot more interesting stuff we could do. Perhaps we could even like hook in, like let them reply to say, what do they want to do as a result of this? And then we could have like an even more personalized thing. Like if they say, oh, I don't like that flight, I just want to, I'm happy to wait. Like maybe we could go, okay, cool, you can wait. Then actually that means we'll give you, I don't know, like a voucher to go and spend it in the airport at the specific food outlet, whatever you want. Like there's kind of multiple ways you can take this. So consider this a starting point rather than an end. And just a quick reminder of the tool stack. So Elizabeth has posted a bunch of stuff for Redpanda. So we've used Redpanda. Redpanda is kind of sitting, it's like the core of this application. So all the streams are sending messages in there. We've then used Quicks to kind of act as like the backer for all of our services and to filter the events and find the relevant ones. Pinot is kind of giving us the latest state, like what is the state that we're going to offer, what is actually happening with each of these flights. And then finally, we've used OpenAI to generate the notifications. And as Dunith pointed out, there are lots of tools in here, and there are more every day. Like if you follow Hugging Face on LinkedIn, the amount of new notifications of messages they have every day is unbelievable. So there's always new stuff going on. And then we were kind of trying to think of some more. So Dunith mentioned a few, but these are some of the other ones. So we thought like marketing a product, like can you come up with like more customized emails to send out?
I guess Mark lost his connection, so let me fill him in. So basically, he was talking about writing cold emails based on the customer interactions being observed for a long time. So we can have a personalized and message catered to each individual customer, so we can drive more engagement. And then I think live commentary on sports events like ball by ball action, especially in a tennis game like Wimbledon, so we can have a generated commentary. Yes, I think we lost Mark. Right. I think that's what he wanted to highlight here. Yeah, I think we are ready to wrap it up. Yadin, you want to wrap it up?
Yeah. So just before we wrap out, any question about anything in the presentation?
He's back.
He's back.
I was thinking that Dunith was unusually still.
It's not me. You're back.
I was like, wait a minute, Yarden is unusually still as well. This is broken. Okay.
I just filled you in about the last slide. Do you want to talk about it real quick?
Yeah, so I don't know where my internet went rogue, but yeah, we were just talking about some ideas of things that you could do. So like live commentary is sort of done by humans, but humans have a limited number of events that they can watch at the same time. So it could be that we could be actors like, I don't know whether any of you ever followed BBC Sport, but they do live commentary on football matches, tennis, and then they bring in like extra commentary from the other matches that are happening that they don't have a person like full-time live streaming. And so it could be like quite useful for that. So we go, hey, tell me the interesting thing that's happening in this match. And it's got all the events of all the, I don't know, all the shots, all the goals, whatever's been happening. It maybe has some interesting stats from the background. So you could come up with like quite a compelling like live commentary to sort of go alongside the human stuff. And then another one that I think would be quite cool, and I've kind of been using ChatGPT manually, is like, can we like tell it like, hey, you can see the curriculum for, I don't know, maths in UK schools. My child doesn't know how to do this and this and this. Here's a recent test that they did. Here's the answers of what they don't know how to do. Give me a personalized next thing that they should practice. I think it'd be kind of really cool for that sort of thing. Like if you build like an online resource. And I think that's more or less it. So don't forget the t-shirt.
I see, sorry, Mark and Dunith, I see a question on chat from Priya.
Where's it? Hang on, find the chat.
I see that the customer data is passed to the model which does not follow the responsible AI principle privacy. How do you stop the user data being sent to the model?
as I understand that, but I mean, that data is all made up. So first of all, it's not some real data. We generated it with Faker. I don't know what you would do. Like, I know that they say that they don't use that data in training their model. I guess if you, for this particular thing, if you were not happy with the principles that one of the model was using, it is actually possible to run those models on your own hardware for Hugging Face, not for OpenAI. So you can actually download them. They are massive. Like even the small, they say like, hey, you can download this small model and it's 20 gigabytes. So the bigger ones are much bigger, but you can certainly, if you have the hardware, you could, there are ways that you could go and host that thing yourself on AWS, and I think even on Azure. And so that would probably be the way that you would want to go. If you had that customer data, yeah, you don't want to go and send it to the OpenAI kingdom, who are going to use it to probably use it, even though they claim they are not, to enhance the model. Somebody's asking for the t-shirt link. Hang on a minute, get the t-shirt link.
Yes, so
I've got the t-shirt, but Dune has told me I had to be StarTree branded, otherwise I could have worn my Redpanda t-shirt.
Everybody loves Panda.
So folks,
yes.
If you want to get a, first of all, thank you, Mark and Dunit, for this great presentation. Thank you. The recording of this presentation will be available on the StarTree channel. We will share updates on our StarTree Slack. Every recording or meetup that is being recorded, we'll let you know, guys, when it's up on YouTube. We will share the recording. Obviously, Redpanda will share it within their own community Slack. Yeah, if you want to get a Redpanda t-shirt, fill out the form that was, fill out the link that Elizabeth just sent via chat, and you can get this cool t-shirt. As for the book, Building Real-Time Analytics Systems, that Mark wrote, scan the link and get an access for free trial for 10 days, free access for the early release of the book, and let us know, or let Mark know what you think. We're happy for a feedback. With that said, thank you so much. If anyone has more questions, feel free to reach out to Mark and Dunit on social or on Slack. We share the links on the chat, and wishing you a lovely day. Thank you.